Alright, welcome to lecture 5.5. So now we are looking at things called the inverse functions. So if you recall, we have the 6 trigonometric functions, and then, as usual in math, we always start to look at the inverse functions. That basically, for an inverse function, is if we have this normal line right here, the y equals x line, and then we swap the x values for the y values. Okay, so whatever x value we have, we would go ahead and swap it to a y value, and we would get something that would be called the inverse function. Now the problem, or a problem occurs when we're swapping the functions from trig. The reason for the problem, if you remember, because these come from the unit circle, these all continue on sort of indefinitely, right? So this is the sine function, it'll go on indefinitely. And if we swap that perfectly, we're going to run into some problems. So let's take a look at some of those problems. Okay, let me go ahead and let's graph the inverse function. But first, before we do that, I'm going to go ahead and plot the normal points that we have for sine. So let's see, for sine, we have our x and our y values. Sorry, I'm going to be squishing it here so that we can see it. Actually, let me put it up a little higher. Let's put this up higher. So we have our sine functions with our normal x and y values. So sine, we have x and then our y values. Let's see, the main ones we have. We have the point 0, 0 for sine, right there. And then we have the point pi over 2, 1, which is right there. And then we have the point pi 0, which is here. And then we have the point 3 pi over 2, negative 1, which would be down here. And then lastly, we have 2 pi 0. Which would actually be out here, but I'm going to go ahead and erase that because I need that space. Okay, so those are the main ones we're going to take a look at. Remember, there are infinitely many of them because the sine function just continues on in waves. So now let's graph the inverse. So sine inverse. And what happens with inverses? Once again, all we do is we switch the x and y values, and we plot them. So swapping x and y for 0, 0, that doesn't matter. But when we swap these values, that'll be 1 pi over 2, then 0 pi, negative 1, 3 pi over 2, and 0, 2 pi. So let's go ahead and do a mini graph of that. Now when I do that, remember we're switching the x and y values, so my pi values are now going to be charted up above. Let's go ahead. So we have pi over 2, pi, 3 pi over 2, and 2 pi. And then I'll do negative 1 and 1. Now this is not to scale, but it's just for a visual. Okay, so let's go ahead and plot those points. 0, 0, 1 pi over 2, 0 pi, negative 1, 3 pi over 2, and lastly, 0, 2 pi. Okay, so I'm going to go ahead and draw that in, and it is a bit of a squished version, but you get the idea. Basically, we've switched sign. And as usual, if you remember, it goes on infinitely. So it's going to start doing something like this in that direction. But I basically just graphed in one period right there. In between these two guys is that. Oops, actually I did that off. Let me take that back. One period. In between the two zeros, so between 0 and pi. That's the usual one period. Now you might be saying, okay, alright, what's the matter? Well, if you recall with functions, they need to pass a certain test called the vertical line test. Okay? Which means if I drop a vertical line, it needs to hit only one point. But when I drop a vertical line here, do you see the problem? We hit definitely more than 1 point. Even in one normal period, we hit 2 points at this spot. So it doesn't pass the vertical line test. So it's not a function. So mathematicians were like, darn. How can we make this a function? We needed to define some rules that we can create a function for sine inverse. Okay, so they decided to define some rules for sine inverse, and they picked a certain period that we were going to look at for sine inverse. And that period, if you're going to see down below, for sine inverse, we had a period, or a range, excuse me, from negative 2 pi to pi over 2. So that's right here, from negative 2 pi to pi over 2. That is what they defined as sine inverse. And if you'll notice, the domain goes from -1 to 1. Okay. Now, the question is, does that little interval we picked pass the vertical line test? And the answer is yes. If I drop 1,000,000 vertical lines, it only hits in one place. So once again, right there we have our sine inverse. Okay. And this concept basically is where we pick all of the different inverses for all of the 6 functions. I'm not going to go over the exact same explanation for all of the functions and how we get the inverses, because it will take a little bit too long. But if you have questions, feel free to set up an office hour with me, and I'll be glad to go over them with you. Alright, so because of that, because of the problems with inversing sine, they created restrictions, and so here are our restrictions. Inverse sine function has a domain -1 to 1 and range -pi/2 to pi/2. And how it's defined? Well, sine inverse is basically when you swap the x and the y values, which is what we did to graph it. And we have some canceling properties, because as usual, the inverse functions have canceling properties. So if you have sine and you input sine inverse, you can cancel the two and just get x as long as the value of x is in between 1 and -1. Okay? If they're in between 1 and -1 and we have sine inverse on the inside, we can cancel it. Got to be careful though, it's not reciprocal. Okay? So if we have sine on the inside, not sine inverse, we can still cancel and just get back x as long as x is in between -pi/2 and pi/2. Once again, there is an explanation for this, but it's kind of long for this video, so if you want to know, please send me an email and set up an office hour. Okay, now let's do some evaluating. Sine inverse of 1. Well, one way I like to evaluate this is we're going to go ahead and use this definition up here. Sine inverse of some value equal to y, and then we can swap it. So I'm going to do that. I'm going to say, you know what? Let's set this up equal to y. I know by definition that it must mean that sine of y should equal the value on the inside, 1. Okay, so I notice I swapped. I'm no longer using the inverse. I'm now just taking a look at sine. And how come I could do the swap? Because of the definition right up here. Okay, and I swap it because it helps me solve it easier. So then we're going to ask ourselves, when does sine equal 1? Looking at the unit circle, sine is equal to +1 up there at pi/2. So our answer will be y equals pi/2, or you would just write sine inverse of 1 is pi/2. Alright, so now let's take a look at the next one. Go ahead and see if you could solve that one by yourself and check in with me in a sec. Alright, well let's go ahead and set this up equal to the y for solving purposes. And this is my so-called x value. So, to solve this, I know that sine of y should equal that half. So when is sine equal to a half? Well, if we look at the unit circle, sine is equal to a half at pi/6. Which means that sine inverse of a half is equal to pi/6. Once again, though, if you did introduce y, you could just write y equals pi/6. Either one of these. Alright, let's keep moving. Feel free to pause the video and try C and D by yourself. There'd be definitely some good exercises for you. Alright, so sine inverse of 2. Let's see. Okay, so we're going to go ahead and set that equal to y. I'm going to stop with the color coding for now. So we have sine of y should equal 2. Oh, we have a problem here. What's the problem? Well, the number 2, that is outside of our domain. Okay? Remember, our domain is between 1 and -1, and 2 is outside of it. So that means it does not exist, because we defined it strictly to be within -1 and 1. So that does not exist, so our answer is just going to be does not exist. By definition, it does not exist. Now let's take a look at the next one. Okay, so we'll go ahead, set this equal to y to solve for the inverse. That means sine of y, we want to know when that equals negative root 3 over 2. So when does sine equal negative root 3 over 2? Well, that's at 4 pi over 3. So the answer would be sine inverse of negative root 3 over 2 is going to equal 4 pi over 3. Once again, you could just write y equals 4 pi over 3. All right, so the next ones. Ooh, so we have something here. We have the double signs going on. We have a sine inverse and a sine. So we could possibly use the cancellation properties as long as we keep in mind these restrictions here. Okay, so let's take a look at the one we have here. We have sine inverse of sine of 0. That is referring to this one right here. Now let's check our x value. Is x, in this case, 0, in between negative pi over 2 and pi over 2? The answer is yes, it is. Awesome, so since it satisfies the restrictions, we can just go ahead and do the cancellation. And that just equals 0. Super nice and easy, huh? All right, now let's take a look at the next one. We have sine inverse of sine of pi. That is referring to this one again. Now, the question is pi in between negative pi over 2 and pi over 2? The answer is no, it's not. Darn. Okay, so we can't use the cancellation property, which means we gotta do this the old-fashioned way. First, let's take a look at what's inside and simplify it. Sine of pi. Well, what is sine of pi? Let's take a look. Sine at pi is going to be, well, the coordinate is 0. Sorry, the coordinate is negative 1, 0. So sine is 0 at pi. So this means sine inverse of 0. The next question is sine inverse of 0. Well, let's go ahead and solve that the way we were solving them previously. Let's set that equal to y. Now we're looking at sine of y equal to 0. Notice we've switched from inverse to regular sine. So the question is, when is sine equal to 0? As sine is equal to 0 at 2 points, pi or 0. Now we can't choose pi. Why not? Well, that is not within our domain. Okay? So since that's not within our restrictions, we'll go ahead and choose 0. So our answer is y equals 0, or you could just rewrite the whole thing again. Write sine of sine pi equal to 0. Now let's take a look at the next one. Can we do the cancellation property? If we can avoid all the work we just did for f. Now let's see. So we're looking for sine inverse. So that is the top one. What are the restrictions? We have the x value needs to be in between negative 1 and 1. Is square root 2 over 2 between negative 1 and 1? Yes, I believe that's 0.7. That's the approximation. So since it is, aha, we can go ahead, cancel. So beautiful if you can cancel. Now let's take a look at h, the last one. We're looking once again at the top version, so sine inverse. Now let's take a look at our x value. Is that in between 1 and 1? Sorry, negative 1 and 1. The answer is no, it's not. So darn, we cannot use the cancellation property. We got to go ahead and do this the old-fashioned way. So we're trying to figure out when sine inverse is equal to pi. Okay, so sine inverse equal to pi. Okay, we're going to have to do that the other way. So we have sine inverse equal, sine inverse of pi, equal to y. We want to figure out sine of y equal to pi. And sine, darn, this doesn't work. You know why this doesn't work? Because recall, sine is bounded by 1 and negative 1. So this does not exist. Does not exist because sine is bounded by negative 1 and 1. So the answer is does not exist. Alrighty, well that was interesting. Let's go ahead and take a look at cosine. Okay, so once again, we have the original cosine function, and mathematicians were like, hey, why not? Let's take a look at the inverse like we do with every other function, huh? Okay, so because it's continuous, they knew there'd be a problem if we went ahead and made the inverse, because we would have this continuous function going on, and then we would have a problem with the vertical line test dropping through, right? So they said, you know what? Let's go ahead. By definition, we'll restrict this to between here and here. And that little snippet of cosine will fit perfectly into the vertical line test. Then they said, alrighty, so with that, the domain is from -1 to 1, and a range is from 0 to pi. And then once again, we have that inverse property for functions. Oh, and one thing I forgot to mention for sine. So whenever you have an inverse, there's another way of saying it. Instead of just saying inverse, you could say arc and then the original function name. So arc cosine is the same as cosine inverse. And then arc sine is the same as sine inverse. Okay, so then the canceling property is very similar to what we had for sine, except the domains are a little bit different, because once again, these are different functions. So this is the domain for here, and this is the domain for this, or the restriction. You could look at it that way. So now let's go ahead and do some evaluation. If you'd like to pause the video and try evaluate these by yourself and check in with me, you're totally allowed to do that. I can't stop you. Okay, let's see. Cosine inverse. Once again, I'm going to use that same method we used for sine. Let's go ahead and set this to y. So then I'll switch to regular cosine. So cosine of y equal to 1. When is cosine equal to 1? Well, cosine is equal to 1 right here at 0 or pi. Okay, so we have 0, and it's also considered 2 pi. Sorry, I meant to say 2 pi. The question is, which version is correct? Well, if we're looking at the domain for cosine, it is in between -1 and 1, so we're going to go ahead and pick 0. So y equals 0. Or once again, you could write cosine inverse of 1 equal to 0. Now let's take a look at the next one. So cosine inverse of a half. Once again, my method is always to set it equal to y and to solve it that way by switching to regular cosine. So cosine of y equals a half. Well, when does cosine equal a half? Cosine equals a half at, right here, pi over 3. It also equals a half down here, but that is not within our domain. So remember, we have to stick to the restrictions. Those are very important. So the answer would be y equals pi over 3, or you could write out the longer version like I did before. Either one is acceptable. If you introduce y, you can answer with y. If you don't introduce y, you need to answer with the original version like that. Alright, and once again, notation is something I grade on. Alright? So please bear in mind the notation that I show, that's pretty much what I grade based on. Alright, so this is going to go ahead and say y. So then cosine of y equal to 2. When does cosine equal to 2? Well, 2 is outside of our domain. So that is undefined, or we would say does not exist. So you could give two different answers. Undefined / does not exist. Because once again, that is outside our domain. Or it is outside of the restrictions for cosine. Now let's take a look at cosine inverse of -√2 over 2. Okay, setting that equal to y. Cosine of y equal -√2 over 2. When does cosine equal -√2 over 2? Well, on the unit circle, it's either at 3 pi over 4 or 5 pi over 4. The question is, which one of these is within our domain? And that would be 3 pi over 4. So y equals 3 pi over 4. Alright, and as usual, boxing our answers, just in case our work is messy. It's easier to find them. Hopefully your work's not messy, though. Makes it easier to grade if it's neat. Alright. Next, okay, we have the cancellation properties. So let's go ahead and take a look here. Which version do we have for E? For E, it looks like this one. And the restriction for x value should be in between 0 and pi, and that's not in between 0 and pi. So we can't use the cancellation property. But we could go ahead and still evaluate and see if it possibly exists. Alright, so let's evaluate cosine of 2 pi. Cosine of 2 pi is equal to 1. Alright, next we'll go ahead and continue on. So cosine inverse of, and we had cosine of 2 pi was equal to 1, so plop that in. And then cosine inverse of 1. Well, let's set that equal to y. So then cosine of y equal to 1. Well, when is cosine equal to 1 within our restrictions? And that is at, let's take a look. cosine is equal to 1 right there at either 0 or 2 pi, but 2 pi is outside of our restrictions, so we'll go with 0. So y equals 0. Once again, it's very important to remember the restrictions. That is often kind of where students get problems when answering, because they have forgotten the certain restrictions for each of the different functions. Alright, so now let's take a look at f. Okay, this time we're looking, still same thing, cosine inverse. So our restriction for x is that it needs to be between 0 and 2 pi. And the question is 2.68 in between 0 and 2 pi? The answer is yes, because remember, pi is roughly 3.14, and 2.68 is smaller than 3.14. So we can go ahead and use the cancellation property, Sam. So that's just going to equal 2.68. Awesome. Now let's take a look at cosine inverse of root 2 over 2. So that's talking about this one up here. Now what are the restrictions for x? X needs to be between -1 and 1. Is root 2 over 2 in between -1 and 1? The answer is yes, it is. So, lucky for us, we can go ahead and just use the cancellation property, and that equals root 2 over 2. Now let's take a look at this one. This is a typo, so sorry if you could go ahead and cancel that out. That should be cosine of cosine inverse of 2. For some reason, my cosine inverse got dropped. So now let's take a look. Can we use the cancellation property? Well, no. 2 is not in between -1 and 1. Then let's take a look. Cosine inverse of 2. Does that exist? And the answer to that is going to be no, it does not exist. 2 is not in the domain. We could possibly have evaluated this if it had been the reverse, but we can't. Okay, so the answer is going to be does not exist. Let me go ahead and erase that. And then write D and E. And once again, I don't know if I explained that, I forget now. You can write D and E, capital D and E, for does not exist. Okay, chugging along. Now, we have the next one, which is inverse tangent function. So, I'm not going to go into too much of the definition on how we get inverse tangent function, but remember the method is you swap the x and y's, and when you do that, you get the thing that looks like this. Now, the wonderfully odd thing about tangent is that when you flip it, it actually is like a perfect inverse function. They really didn't have to piece it up too much. Mainly because it already is sort of restricted beforehand with all the asymptotes. That's kind of where it comes from. But because of that, there is no restriction on the domain. The domain is just going to be -infinity to +infinity. The range, though, the numbers, it does still have the asymptotes when you flip it. So remember the asymptotes exist along here. I'll just go ahead and draw that in and then make it... Sorry, that is a terrible asymptote line. Bad example as a teacher. Okay. So, there we have our really terrible looking asymptotes. Let me fix that. I can't handle leaving it like that bad. So wherever -pi/2 and pi/2 are, we would have the asymptotes. So our tangent function doesn't ever go past those, which is why our range is still sort of restricted. Or it is restricted. And then once again, the usual definitions for inverses, you swap the x and y's. And then the inverse, that should say tangent. The inverse tangent function is also called arctangent, or denoted by arctan. Now the cancelling properties. So if we have tangent of tangent inverse, it equals x for any number. Isn't that beautiful? We don't have to worry too much about the restriction if the inverse is on the inside. It's wonderful. However, we do have a restriction if we have the regular function on the inside and tangent on the outside. The restriction for that is going to be -pi/2 to pi/2. Alright, so one thing I'll quickly mention, just a little reminder, is the domain is the input value, and the range is the output value. Input meaning this value, output meaning this value. Or another way to say input, output. Input, output. Alright, now let's take a look at some evaluation problems. So evaluate tan inverse of 1. Well, once again, as usual, we're going to go ahead and set this equal to y and try and solve. So setting this equal to y, we'll go ahead and switch to regular tangent, so tangent of y equal to 1. Well, when does tangent of y equal 1? There are a few places, if you recall. We have it over here and over here, both at pi over 4-ish values. However, we have to think about our restrictions. And our restrictions state that that needs to be in between pi over 2 and negative pi over 2. So that means we're going to go ahead and pick the pi over 4 value. Bloop. So y equals pi over 4. And moving on. Tangent inverse of tangent inverse of root 3. Alright, let's go ahead and set that equal to y, solving, so tangent of y equal to root 3. When does tangent equal root 3? Well, I don't know that specifically, but I'm trying to think. So remember, tangent is y over x. And we want to end up with the root 3 on the top. So that means we'd be using root 3 over 2 and half, right? Either the positive versions entirely or the negative versions entirely. But remember, the negative versions would be coming from quadrant 3, which we're not going to be using. So we'll be using up here, and that point is from pi over 3. Alright, so y is going to equal pi over 3. So once again, that took some guessing work. We had to figure out which coordinate values would cancel and give us that perfect root 3. So definitely making sure you know your unit circle. I would definitely say memorize it, because it takes time trying to look these up all the time. Alright, so tangent inverse of 2. So go ahead and set that equal to y. So then we're looking for tangent of y equal to 2. Now, I cannot think of a way to finagle a y over x value to get 2. So this is when your beautiful, glorious TI-84 calculator shall come into play. Once again, on exams, please do not be using your phones. The question is why? Because on the final exam, you're not allowed to be using anything that has access to technology, access to the internet, but you are allowed to use your TI-84 calculators. So make sure you know how to use them. So practice using them for all of your exams. So this is when you'll go ahead, since we don't know how to use this, or how to find this with the unit circle, we'll go ahead and input tangent inverse of 2 on our calculator. So when you do that, hit second tangent, and that's going to give us tangent inverse, and then you'll do 2. Now when we plug that into our calculator, we'll get out that y is approximately 1.071. Now when we start using the calculator a lot more in the course, I'll go ahead and include it in videos, but at the moment, it's not a main portion of this section. So now, let's take a look at tangent inverse of negative 1. And that'll equal y. Oh, one thing to note. On the exams, there will be sections where you should be using your calculator, which means you can give decimally answers like this from a calculator. And there are other times when you should be doing it by hand, which is, at the moment, for our sections, basically should be doing it by hand. Okay, and that's when I'll be expecting answers from doing it by hand. Okay? And that'll be mentioned on the exam. So if it says do not use calculator, you should not be using the calculator to find your answers. Okay. So let's see, tangent of y equals negative 1. When does tangent equal negative 1? Well, let's see, we have a few options. Negative 1, that's going to be here or here. Now, if you recall, we have to keep in mind the restrictions. So we're allowed to go between negative pi over 2 and pi over 2. Let me go ahead and highlight that. So restriction is between negative pi over 2 and pi over 2, which means we only have the option of right there, which we would usually call 7 pi over 4 when we're talking about the unit circle, but we have a problem here. 7 pi over 4 is not within our restriction. So since it's not within our restriction, we have to be careful. We need to think of this a little more cleverly. So let's go ahead and notice our restriction, we can go into the negatives. So if we go into the negative direction, that'll just be negative pi over 4. Okay, so using that distinction of moving, which direction we're moving from 0, if we move in this direction, we can go ahead and use the negative pi over 4. So there we have that y equals negative pi over 4. So just sneakily finding a way to fit into our restrictions. All right. Ooh, okay, so let's see if any of these cancel. So we have a bunch of our tangent and the tangent inverses. So tangent inverse 2 pi, that's talking about this one. Now the question is 2 pi within our restriction? And the answer is no, it's not. So we cannot cancel, which means we got to go ahead and evaluate this the long way. So we're looking at tangent of 2 pi. What does that equal? That equals 0. So tangent of 2 pi is 0. So then we're looking at tangent inverse of 0, which equals y. Okay, and then that means, let's see, okay, so tangent of y equal to 0. So when is tangent equal to 0? At 0. Y equals 0. Now let's take a look at the next one. Tangent inverse of tangent of 2.68. Once again, still looking at the bottom one. So the question is 2.68 in between our restrictions? And it's not. So you could go ahead and use a calculator here. So using the calculator, once again, the TI-84, which hopefully you have, and that's going to end up equaling approximately, so once again, when you do approximations, please use that approximation symbol, negative 0.4615, and it goes on. Alrighty, so roughly about there. And on exams, I'll tell you what to round off to, and if I do not tell you what to round off to, go ahead and just round off to 2 decimal places. That is what the default is if I do not tell you. Okay. Alright, now let's take a look at G. Tangent of tangent inverse square root 2 over 2. Well, that's talking about the one up here. And what do you know? The restriction is all real numbers. Isn't that beautiful? Okay, restriction's all real numbers. Let's go ahead, have a heyday, cancel these out. And we're just left with root 2 over 2. Glory. And once again, for h, we don't have restrictions on the x value. Haha. So we'll go ahead, cancel that out, and we're left with 2. Once again, glory. Okay, so that is it for tangent inverse. Now let's take a look at the other inverse functions. Sadly, we do not give them as much glory as their counterparts. They're all just sort of stuffed into here. Okay. Once again, all of their different domain and ranges come from restricting their inverses so that they fit the vertical line test. So secant inverse has this domain, infinity to 1, 1 to infinity. Ooh, that is a typo. For infinity, we do not include infinity. And then a range of 0 to 2 pi, sorry, to pi over 2 squared. I can't believe I said pi over 2 squared. 0 to negative pi over 2, union pi to 3 pi over 2. And it's defined by, as usual, you just take the x and y values and swap them. Now, cosecant inverse has a domain of, ooh, once again, oh, typos on my infinities. That is not good. I'll have to change that. Okay, so domain of negative infinity to 1, union 1 to infinity. And a range of 0 to negative pi over 2, union pi, 3 pi over 2. So notice the difference between secant and cosecant is which values are included. If you'll notice, 0 is included for secant, but not for cosecant. And then it's the exact swap for pi over 2. Sorry, the negative pi over 2. Once again, it swaps for these guys and for those guys. So be aware of when it's including or not including. And then as usual, we're talking about swapping x and y. And then for cotangent, the domain, very similar to tangent, is negative infinity to positive infinity, which is awesome. And then the range is from 0 to pi. And once again, we define that, and we swap the x and y's. Now, the names for these are basically the same concept as we had before. Inverse of secant is arcsecant. Inverse of cosecant is arc cosecant, and inverse of arc cotangent is arc cotangent. And I'm aware there's a small typo there, so I'm going to try and fix these before you guys get to these notes. Now let's take a look at some evaluating. Let's take a look at the first one, secant inverse of 1. Alright, as usual, let's go ahead and set that equal to y. And then we're looking at secant of y equal to 1. Now, if you recall, secant is the same as 1 over cosine of y. So when is this equal to 1? Well, that is equal to 1 when cosine is also equal to 1. Right? Because then we would have 1 over 1. So the question is, when is cosine of y equal to 1? Well, cosine of y is equal to 1 at y equals 0. Right? On the unit circle right here, cosine is equal to 1 at y equals 0. So a little tricky, we had to go back to cosine. As usual, most of the time, you'll find yourself going back to sine and cosine, because they tend to be the more straightforward ones, right? They're just equal to x and y. The other ones tend to be fractions, which make them a little more complicated. Now let's take a look at cotangent inverse of root 3. Set that equal to y, and then we'll have cotangent of y equal to root 3. Now, if you recall, cotangent is x over y. So how could we end up with root 3? Well, a point I can think of is if we had x equal to root 3 over 2 and y equal to a half. Now that point, root 3 over 2, half, or, remember, if they were also both the negative, those would both give us that root 3 as our answer. Now where do those points exist? Well, those points exist, wrong dot, over here at pi over 6, and also down at 7 pi over 6. However, 7 pi over 6 is not within our restriction, so we're going to go ahead with the pi over 6. So we have that y equals pi over 6. Now you do not need to show the drawing of the unit circle like I'm just erasing right here. You don't need to show that for your work. Just show the work that I have written in black. However, if you do have that side work, on the exams, forgot to mention this. If you do have scratch work and you don't want me to grade it, as in you don't want me to look at the notation or grade any of that, write scratch work. However, because I do grade you based on your work, you still need to show work. So do not put all of your work in the scratch work, because if it's all in the scratch work, I will not grade it. For example, what do I mean? If you put all of this in the scratch work, and you just left this as your answer, you might only get 1 point out of 2. Why? Because I'm also grading for work. So basically, scratch work is just for your messy work that you're thinking about, and your regular work is for your nice final presentation on what the answer is. Okay, so bear that in mind. Okay, so a small typo. Sorry for the typos. Once again, I hope I have fixed them in your videos. So this should be cosecant. Alright, so we have a cosecant of cosecant inverse of a half. Now we're going to set that equal to y to solve. So that will be cosecant of y equal a half. Now once again, just like we did for secant, we went ahead and moved it back to cosine. Let's do that for cosecant. So move that to sine, which is the inverse of it, it's in 1 over 2. Equating this problem, this is saying, when is sine of y equal to 2? How do we do that? We just equated it. Shorthand. Let's see, sine of y equal to 2. Well, that is outside of our domain. That does not exist. So answer would be, does not exist. Now let's go ahead and evaluate for example 5. Tangent inverse of sine inverse of 0. Well, we can't do any of those cancellation properties because that only works for a function and its own inverse. These are two different inverse functions, which means we're going to have to simplify inward and slowly work outward. Well, sine inverse of 0, what is that going to be? So set that equal to y. That means we're looking at sine of y equals 0. And sine of y is 0 at 0 within our domain. It is 0 over here, but that's not within the restriction that we have. Restriction would be in between there. So that means y is 0. All right, moving on. So we're looking at, tangent inverse of 0. Set that also equal to y. So notice, I'm not writing these two directly above each other. These are two separate looking sort of things. So make sure to keep your work separate. Go ahead and write so. And then, let's see, that means tangent of y equals 0. So when is tangent 0? Tangent, if you recall, is y over x. So that means that's whenever y is 0, which is at this point and this point. So either 0 and 2 pi or pi. However, for the restrictions on tangent, it's just going to be 0. So y equals 0. Now let's look at cosine inverse tangent pi over 4. Once again, we can't use any of those nice cancellation properties, so we're going to have to work this out slowly on the inside. So what is tangent pi over 4? Well, tangent of pi over 4, remember pi over 4 is here, that's root 2 over 2, root 2 over 2. So that's just going to be root 2 over 2 divided by root 2 over 2, which will just be 1. Let me write that out. Because any number divided by itself is equal to 1. So that is 1. So we're looking at cosine inverse of 1, and we'll set that equal to y to solve. Then we're looking at cosine of y equal to 1. So when does cosine equal 1? Well, it equals 1 at, let me go ahead and label that point, at 0 or pi. But, sorry, not pi, 2 pi. But to stay within our domain, we're going to go ahead with the 0. So y equals 0. So it's again the side work. Notice I did that on the side and then I continued after. The reason why is these two are not equal, so we should not line them up directly above each other, because then it looks like you're telling me they're equal, which they are not. So be careful with how you show your work. Alright, let's see. Next, okay, once again for C, we cannot use any of our cancellation properties, so we're going to have to go ahead and do the small evaluating on the inside. So sine inverse of root 2 over 2, set that equal to y. Sine of y equal to root 2 over 2. When does sine of y equal to root 2 over 2? Well, that's at pi over 4. So that's going to be tangent of pi over 4, and tangent of pi over 4 is equal to, as we did before, right up here, 1. Ooh, that was a nasty box. Alrighty, fixed that. Now 3 more to go. So, okay, as usual, always feel free to pause the video and try these out by yourself and check with me. That's a really great way to make sure that you understand the material yourself, not just while I am sharing it. Because a lot of the times, it's harder when you're doing it by yourself. Because that's when you're really stretching your knowledge. Which is good, though. You want to be able to do that. So for D, cosine inverse of a half. Well, let's see. Cosine inverse of a half. Did we do that previously? I believe we did. But let's go ahead and do this now. So cosine inverse of a half. Practicing this out, we'll set this equal to y. So we're looking at cosine of y equal to a half. So when is cosine equal to a half? Let's go ahead and do this down here. Cosine is a half at pi over 3. So y equals pi over 3. So then we'll go ahead with our work on the side here. So we have sine of pi over 3. What is sine of pi over 3? Sine of pi over 3. So this point is a half root 3 over 2. The answer would be root 3 over 2. Alright, let's go ahead and get this cleaned up. Now we're looking at cosine tangent inverse of 4. Well, if you recall, tangent inverse, the input values, we have no restrictions, so that's perfectly fine, even though 4 is a pretty big number to be seeing. But because we don't have those numbers on our unit circle, this is when we're going to use a calculator. And remember, to get tangent inverse, you're going to hit secant and then tangent. And then we get about 0.24. Okay, so basically, the only time we've used calculators so far for this section is with tangent inverse. Now let's take a look at the next one. Sine inverse of cosecant of pi over 6. Well, let's do the inside. So cosecant of pi over 6, what is that going to be? Cosecant. Cosecant is, let's see, it's going to be the reciprocal of secant, and we're looking at pi over 6, right? Sorry, not the reciprocal of secant. It's going to be the reciprocal of sine. So let's see, at this point we have root 3 over 2, a half for pi over 6, and we're looking for sine, because cosine is the reciprocal of that. So it's a half. What's the reciprocal of a half? Well, that'll just be 2. So cosecant of pi over 6 is equal to 2. Alrighty, awesome. So we found that. So sine inverse of 2. Ooh, okay. 2, that is going to be outside our domain for sine inverse. Because if you recall, the domain for sine inverse is -1 to 1. And 2 is bigger than that. Because of that, our answer is going to be does not exist, or you could write undefined. Okay, that is it for 5.5. Once again, these are the practice problems, which should be uploaded by the end of the week. Once again, they are not graded, so you do not have to worry about turning those in on Fridays. Those are just for your own personal practice problems. If you have any questions, please send me an email and we can set up an office hour.